In this lecture, we will have an overview of managing indoor air quality from urban scale to personal or the room scale. First, we will look what could be done at the urban scale. So this is schematics or a illustration of how an urban area looks like, with a lot of buildings, some open areas in between. So this how to manage the quality here. One can introduce more fresh air to the street canyon. So here fresh air been introduced to the interspersed space between the buildings, so that the outdoor air is refreshed. Simultaneously, arrange the building geometry which allows for this fresh air move downwards towards the building canyon. Reduce the outdoor emission sources. Provide some urban greening situations. One can also use large scale cleaners and change the street sort of arrangement. And finally, one can have more ventilation provision by reducing, for example, the urban density in a newly planned area, both in terms of plan and frontal density. When we come to the building scale, in the building we can provide more ventilation. We can have more natural ventilation, maybe by a solar chimney. One can install low emission building materials so that the source is controlled. One can try to reduce microbe generation and growth in HVAC ducts. Have outdoor air, manage the outdoor air of the HVAC systems, the air which is coming inside. Install filtration and disinfection, and maybe also install pollutant sorption materials. So all this way, maybe at the building scale also some control can be made. Then coming at the room scale, one can optimize ventilation. One can put partitions to manage the airflow. Use some advanced air distribution system so that everyone gets fresh air. Control the emissions from devices such as our photocopiers. Install low emission furniture, so this will be a source control, and have purification and cleaning techniques. At a complete personal scale, and this is an extreme case of course, like one can reduce source control from local exhaust. One can reduce emissions from upholstery, for example. Then one can provide some personalized air ventilation, which is basically clean air coming to the breathing air zone of the participant. Have some wearable air cleaners, and then wear personal protective equipment. So maybe not coveralls, but maybe mask. But generally, we do not want to come to this stage. We must be able to control the source and manage the air quality at the urban and building level itself, and try to avoid coming at the room level, because there are anyways room specific sources such as kitchen, cooking, which need separate attention. So everything else should be actually managed before. So the indoor air pollution can be controlled at source by elimination and modification of the source at the receptor, by regulating the occupant behavior, and by changing the pathways. So disrupting the pathway of pollution flow by ventilation, or installing the equipment for pollution control. Source elimination and modification will remove the causative pollutant from the indoor environment. Example is smoking bans. If elimination is not possible, one can modify or substitute. For example, minimize the magnitude of pollutant release, or substitute the pollutant or the source with a less hazardous alternative. An example could be the use of LPG based cooking or use of electrical cooking as an alternative to biomass based cooking, and this can lead improvement in lot of air quality in terms of pollution by carbon monoxide, nitrogen oxides, hydrocarbons, soot concentrations and other particulate matters. One can use an appropriate choice of building products and the personal goods. One can also provide barriers for barriers around the source so that the source itself is isolated. At the receptor level, one can provide education and sources. Receptor is us, the humans. One can provide education and sources, pathways and health effects related to indoor air pollution. Create consumer awareness on products and materials that can reduce pollutant release. One can also encourage adoption of building rating systems, for example GRIHA or LEED, for the use of sustainable or suitable construction protocols. One can do distancing of receptors from direct exposure to contaminants, or move the receptor, which is humans, to areas of highest ventilation or areas of high dilution, so that we are the source is still there, we are just moving ourselves to a place where there is less pollution. Finally, one can use personal protective equipment, but also that is maybe a more extreme case, but one can always practice personal hygiene, maybe use labels and warning systems for pollution, indoor sources of indoor air pollution, do pollutant monitoring, maintain housekeeping and employ disinfection practices. So ventilation we have already seen. So just to recap, it will be air supplied to ventilate an enclosed space, and it will help one to give a chemical sort of comfort, which is to maintain acceptable levels of oxygen, dilute CO2 and other contaminants for enhancing occupant safety. The other is the thermal comfort, which is the provision of a thermally controlled environment for occupant comfort by maintaining air temperature, then also relative humidity and the air velocity. The natural ventilation can be done through placement of openings, so doors and windows. Also we have seen options like having a solar chimney. The advantage is that the operational cost, the capital cost and maintenance cost are low, but the performance would be variable depending on the conditions indoors and outdoors. Therefore, they would be less preferred when we actually have poor ambient air quality, for example outside, or where there is privacy or security concern, or we have a densely populated situation with high densely populated dwelling units with high energy requirements, and sometimes there is a necessity for like strictly clean air, for example hospitals or operation theaters. So we cannot rely on natural ventilation in those settings, because the performance of natural ventilation may be variable depending on outdoor indoor situation, but here we need strictly clean air. So here we would probably go for mechanical options and install cleaning devices. Mechanical ventilation can be driven by mechanical equipment such as fans, so these are good because they can give us a controlled performance. For example, in hospitals we can in theory achieve strictly clean and consistently strictly clean air. The downside is in some cases they may be generating noise and secondary pollutants. So mechanical ventilation can be provided through the wall, or on the ceilings or the wall. The supply of ventilation is usually treated as a central location. So for example, one can put filter and do some conditioning and then distribute it by a duct system to the intended indoor space, and some grill, slot diffusers, ceiling diffusers, perforated ceilings can be used for this whole process, and this is like how they might look like. Then we already know some systems such as our kitchen hood. So all the smoke emitted from the kitchen, from the cooking process, is sort of sucked in and moved out. The efficiency of the ventilation system will depend on the type of ventilation, as we can imagine. Then the number of occupants in the indoor environment. What is the volume per number of occupants? So is this a small room or a big room? What is the outdoor pollutant concentration? What are the sources and the release rates of indoor pollution? What is the type of pollution control equipment that is installed indoors? Also, environmental factors like humidity and temperature in the indoor environment. Ventilation can often be achieved by maintaining our air changes per hour, which we have done already in one of the previous weeks. And this air changes per hour can be maintained by combining mechanical and natural ventilation systems. To recall, air changes per hour means how many times the volume of a room can be changed per hour. So 2 air changes per hour means the whole volume is basically flushed out 2 times in 1 hour. So those were ventilation systems. Then we have the actual pollution control equipment, whose purpose would be to clean the air and achieve in some specified appropriate indoor air quality. The target pollutant may be particulate, vapor or gaseous. Equipment may employ physical, physicochemical and biological procedures for removal. Mechanical filtration is the first one we will look at. This mechanical filtration can capture particulate matter based on the forced circulation of air through a fibrous material. So basically we are passing the air through a filter. This filtration could be surface filtration, generally for sizes more than 10 micrometer, this is good, or depth filtration for lower sizes. Of course, when we are using filter, the filters would need regular replacements for maintaining the capture efficiency, to prevent re-emissions of pollutants and to avoid microbial growth on trapped organic matter. Efficiencies higher than 90% are achievable in conventional filters, even at high flow rates. These filtration basically are relying on several mechanisms. For example, impaction, so inertial impingement, which is effective on large particles. Interception, which would be like collision with fibers, which is effective than impaction at low velocities. And generally it is for particles bit more than 1 micrometer, but they are also effective. They are somewhat low efficient filters and generally more suitable for using as pre-filters, and sometimes they are commonly used in residential furnaces and central air conditioning systems. Then one can do straining, which is capture of particles passing between adjacent fibers. Diffusion, in which the particle is driven towards filter fiber by rapid molecular bombardment by air molecules, which is generally effective for small particles, but it is an expensive system. But since we can remove very small particles, it is somewhat useful because it can remove inhalant allergic substances, and therefore maybe residential use they may become popular. The mechanical filters are generally effective if particles are remaining airborne, right? If they are not in the air, how will we filter them? And they are transported to a filter in the system itself, otherwise the filtration cannot occur. We have also something called membrane filtration, which is a developing technology for commercial application. It is efficient. It makes for the transfer of indoor air pollutants to another fluid through a semi-permeable membrane. But since we have a semi-permeable membrane and we are passing or forcing the pollutant through, the mechanical resistance and mechanical pressure drop increases are such that the operational costs are very high. Of course, when we remove the pollutant into another side of the filter or the membrane, the recovery and management of pollutants captured on the membranes will become some issues that would need to be addressed. Then we have electronic filtration, in which particles are collected based on the attraction of negatively charged particles to a plate with opposite polarity. Examples could be electrostatic precipitators and the ionizers. These are generally more expensive than mechanical filtration, and when we have plates given for attraction, we need to remove the particles that have been accumulated on the plates. Electrostatic precipitators are medium to high efficiency filters, and they remove particles by providing an electric charge on the particle, and then subsequently they are removed from the precipitator on the oppositely charged plates. Typically they use high direct current voltage to produce a negative corona that may drift particles toward the collecting electrodes. The advantage is that there is low resistance to airflow compared to mechanical filter, because we have basically just charged the particle and when we are letting the particle flow. In mechanical filters we will put a filter so in the path of the flow, which means the airflow would be obstructed. The disadvantages of the electrostatic precipitator are that they can cause a potential hazard due to high voltage at the ionizing electrode, collection plates and charging media. One can also have ozone production possible because we are using high voltages. Then soiling is caused by dust particles to the precipitator itself, so maintenance will be needed. This is just a schematic, so how it could be employed. So these are these kitchen cooking fumes. They are taken up in a fume mode, and then these are passed through a electrostatic precipitator. So we will have the dirty air, then there is charge being supplied, and the particles become charged. So first the air passes through a pre-filter, so remove maybe larger particles. Then the airflow is ionized and is collected on plates. So here positive may collect on negative plates, or sometimes in electrostatic precipitator negatives collect on positive plates, depends on the design and requirement. Then the air filter is air is passed through another filter to make sure there is no remaining particles, and then much cleaner air can pass through. Then we have the ionizers that trap particulate matter by introducing differently charged ions. So the particles in the air will acquire diffuse charges by these ion particle attachments, and these are then attracted to walls, floors, tabletops, draperies and the occupants. So basically different kinds of and all kinds of surfaces. So this will remove the particle from the air, but of course abrasion may result in resuspension of particles back to the air. Also ozone, which itself is a lung irritant and also drives several indoor chemical reactions, as we have seen in one of the previous weeks. This may be produced indirectly by these ion generators. This is a figure sort of illustration where the air ionizer is emitting negative ions to the air. These ions then attach to the particulate matter, bacteria, dust, smokes and viruses, and these then are deposited to not only ground but also other different surfaces, and the air itself may become somewhat cleaner. It has been reported that ion generators may remove the small particles such as from tobacco smokes, but are not that effective in removing large particles such as pollens and house dust allergens. In summary, indoor air pollution can be managed starting from different levels. So it could be urban or urban scale. We may try to have more fresh air in the urban outdoor environment. At building scale, so we make sure that the air that is coming in the building is either fresh or clean. At room scale, same things will apply, and at personal scale, we can have fresh air or we can have protected equipment. But generally, we would want our clean air to already be achieved when we are at the building scale. One can use different cleaning methods and devices. For example, ventilation. So natural ventilation is a bit more variable, and mechanical ventilation, where we can control the treatment by installing things such as filtration, and also using methods such as electrostatic precipitation and deposition, for example through using ionizers. There are also techniques like membrane filtration that are coming up.